For question 2, we have, compute the volume of the solid formed by revolving the region bounded by the graphs y equals x squared plus 1, y equals 0, and x equals 1 about the y-axis using the shell, disk, or washer method. First, we can start by graphing this function. We can start by plugging in values of x into our function to find the y values. So we can use 0, 1/2, and 1. This gives you a value of 1. This gives you a value of 1.25, and this gives you a value of 2. We can then graph this, and then we will have x equals 0 and y equals 1, x equals 1/2 and y equals 1.25, and x equals 1 and y equals 2. We then have this function. We also know that x is equal to 1, so we can draw a line at x equals 1. And we also know that y is equal to 0, which is the same as our x-axis. Now when we rotate this around the y-axis, we get a cylindrical shape. So we know that we can use the shell method. The formula for the shell method is V volume is equal to the integral from a to b 2 pi r h dx. Our r being our radius and h being our height. Now we know that the radius changes with the changes of x, so r is going to be equal to x. The height is the difference between the x-axis and our function, which is going to be the function itself, x squared plus 1. Now we plug in our radius and our height into the integral, and we know that our bounds are from 0 to 1, so we can have a equals 0, b is equal to 1. So then we have v is equal to the integral from 0 to 1, 2 pi x squared plus 1 dx. Next, we can bring the 2 pi in front of the integral and distribute the x and the x squared plus 1, which will give us x cubed plus x dx. From here, we can integrate normally, and we will have v is equal to 2 pi parentheses x to the 4th over 4 plus x squared over 2 with bounds from 0 to 1. Plugging in our 1 and 0, we have v is equal to 2 pi 1/4 plus 1/2 minus 0. This gives us 2 pi times 3/4, which is equal to 6 pi over 4. And that's our final answer.